Why are glacial meltwater channels so important? Imagine a giant ice sheet slowly melting and carving out a network of winding channels beneath and around it. These meltwater channels are more than just scars on the landscape. They tell us a lot about how glaciers behave and change over time. They are like the glacier's diary, revealing past movements and current conditions. These channels form when meltwater from the ice flows underneath or along the edges of glaciers. In warm-based glaciers, where the ice at the bottom reaches the pressure melting point, water can flow directly beneath, creating tunnels called subglacial channels. These tunnels help the glacier slide more easily over its bed, speeding up its movement. In colder glaciers, where the ice is frozen to the ground, meltwater is forced to flow around the edges, forming ice marginal or lateral channels. These channels often stay visible long after the glacier has retreated, acting as clues to where the ice once extended. Studying these channels helps scientists understand how glaciers interact with their beds and surrounding landscapes. For example, in Antarctica, some glaciers have large subglacial channels that carry water from melting at the base to the ocean. This process can speed up ice loss by melting more ice at the grounding line, where the glacier meets the sea. Faster melting here can cause glaciers to retreat more quickly, raising sea levels worldwide. Meltwater channels also influence how water moves beneath ice sheets, acting like lubricants that help the ice slide faster. This increased movement can lead to more ice breaking off into the ocean. By examining these channels, scientists can reconstruct past climate conditions and how glaciers have responded to changes over thousands of years. They serve as natural records of glacial history, especially in places where other markers are hard to find. Including meltwater flow in models helps improve predictions about future ice sheet behavior and sea level rise. So, these channels are vital because they mark where glaciers once stood and how they are changing now. They reveal the thermal state of glaciers, whether they are warm or cold-based, and how fast they are moving. They also help us understand the processes that lead to ice loss, especially in sensitive polar regions. In the end, meltwater channels are like the footprints of glaciers, guiding us to better understand our planet's climate and future.